Okay, our last video for week 4. A spinner has 6 equally sized slices numbered 1 through 6. Some are white, some are gray, as shown below. So we're going to answer the following questions. Write each answer as a fraction. The wheel will be spun and will stop on a slice at random. What's the probability that the wheel stops on a slice with a number less than 5? Okay, well, probability that we're going to get a number less than 5. I think we are all okay with saying, well, that could be this one, this one, this one, or this one. So there's 4 slices out of the 6 that are numbers less than 5, which we could reduce to 2/3. Okay, so no stress on that one. Let's see what the second part of this question is. Okay, we still have the same spinner. Some are white, some are gray. This time they're asking us, what is the probability that the wheel stops on a slice with a number less than 5, given, dun dun dun, that the wheel stops on a gray slice? Okay, so in a previous video, I gave you a hint, Parcells hint, that when you see the word given, you're going to have a change of denominator. Okay, so every time I see that word, my brain is always saying, something's going to change in the denominator, like in that bikini bottom of the basement, of the fraction here. Okay, so we are given that the wheel stops on gray. So we are given that the wheel stops on gray. So that limits us to 4 slices. Okay, so if the denominator has to be that it was given to us that the wheel stops on gray, that means we can't use these slices right here. So our denominator is going to be 4. And then out of the 4 that are left, we are told that we're looking for the probability that it stops on a slice with a number less than 5. So a number less than 5 would be this 1 or this 3 if we're limited to just the gray. So 2 out of 4 or 1/2. So hopefully that makes sense. I think we got another few to practice. Okay, I want you to read this problem. There's 2 problems in here. This is problem A and B. Pause the video, get your answer, and then come back and see me. Okay, the wheel will be spun and will stop on a slice at random. What's the probability that the wheel stops on a white slice? Okay, so we have 8 equally sized slices. Boy, that's a tongue twister. From 1 to 8. So we know we have 8 possibilities. And out of those 8, we have 1, 2, 3, 4, 5 that are white slices. So that's the probability that the wheel would stop on a white slice. I don't think anybody's having any issues with that at this point. I think we're okay with that. Here is where the problems start. What is the probability that the wheel stops on a white slice, given that the wheel stops on a number less than 7? There's that crazy word. Okay, so that's going to change that denominator. So we are given that the wheel stops on a number less than 7. So let's figure out what those are. So it's going to be 6, 5, 4, 3, 2, 1, but it can't be 7 or 8. So since we're given that, that means we have to exclude these as part of our denominator. So what do we have? We've got 1, 2, 3, 4, 5, 6 as our denominator. But then what's the probability that the wheel stops on white? Well, out of those 6 slices, 1, 2, 3, 4 of them are white. So we have 4 over 6, which we can reduce to 2/3. Okay, we're in the last few tidbits of week 4. And this is the last tidbits of probability that we have to deal with. So hold tight. It ends with a bang, and then we walk away from probability. Many of you will probably be thinking, yay. Okay, conditional probability deriving the formula. So we know that the multiplication rule for any two events, when you have dependent events, they really should have put that there, is that the probability of A and B becomes the probability of A times the probability of B, given that A has already occurred. So you could rewrite this as the probability of A times the probability of B. Then you're going to use a pipe symbol. That's the pipe symbol right there. Pipe symbol. Okay. Pipe symbol means probability of B given. So that just means the word given. A has already occurred. So how do you compute this? The probability that a second event B occurs, given that the first event A has already occurred, can be found by this little trusty formula here. We're going to divide the probability that both events occurred right here by the probability that the first event has already occurred. So this is the formula that we're going to use. I'm going to write this out. So the probability of B given A is the same as the probability of A and B divided by the probability of A. So we're going to use that moving forward. All right, so we might be using that formula at some point here, maybe with this Venn diagram. Okay, it's called a double Venn diagram. This is called a universe. Everything inside this box is the universe. And then usually you have event A and event B inside if you have a double Venn diagram here, which we do. So apparently this is a Venn diagram of 14 students. So that would include Dante and everybody in art and dance. They're all in Mrs. Gray's class. So the universe is Miss Gray's class. All these people live in that universe. The diagram shows the membership for kids that are in the art club and the dance club. A student from the class is randomly selected. So A is going to be the event that the student's in the art club. B is the event that the student is in the dance club. Now, Dante is not in art or dance, but is still a member of Miss Gray's class. So here's the outcomes. We want to note that Dante is outside the circle since Dante is not a member of either club, and that's okay. Maybe Dante is not interested in either of these clubs, or maybe Dante is doing a different club. Okay, so this is the same double Venn diagram. It's Mrs. Gray's class. Remember, this is event A and this is B. Everyone's living in this universe is in Miss Gray's class. And then some of them are in art and club and some are in dance. So we have a whole slew of questions we're being asked. So first of all, we want to know what's the probability of A, okay? So probability of A is just the number of people that are in the art club out of all the people. So we have 1, 2, 3, 4, 5, 6, 7, 8 out of 9, 10, 11, 12, 13, 14, 8 out of 14. All right, now that's just the people that is the probability that they are in the art club. Okay, so you just want to think about just the art club. 8 out of 14. Now we know 8's even and 14 is even, so we could cut this into 4 sevenths if we wanted to. Okay, now, so let's just focus on that. Was just probability of A. All right, next one up, what's the probability of B, right? So probability that somebody came in and selected a student at random out of Miss Gray's class that they would be in the dance club is going to be 1, 2, 3, 4, 5, 6, 7 out of 14, which we know that reduces to a half. Okay, so far, hopefully everybody's good. No one's stressed out about this. All right, the next one is A and B. So if you remember, this is the intersection or the overlap or what's in common. Okay, so that's right here. Bill and Jose are hanging out in the overlap. What's in common between art and dance, between art club and dance club? Well, we have 2, Bill and Jose, out of all 14. Now, 2 over 14 we know can reduce. 2 goes into itself once, 2 goes into 14 7 times. So we got 1 7th there. So the first one is 4 sevenths. Probability of B is a half. Probability of A and B is a 7th. Okay. The next one is the probability of B given A, okay? So remember that pipe symbol just means the word given. So I might come down and write just a little bit further down here, a little bit more about that. So hold tight. Okay, I put some notes on here. When they ask us for the probability of B given A has already occurred, what they're saying is they want the probability of B given that A has already occurred. And what is A is that the student is in the dance club. Given the student is in the art club. Hint, given is always the denominator. So I wrote it out as the probability of B given A is equal to the number of students who are in art and dance, so they are in both clubs, divided by the number of students in the art club. So if you want to think about it this way, the probability of B given A is equal to number of students in both clubs we know is 2. Number of students in art class is 1, 2, 3, 4, 5, 6, 7, 8. And 2 over 8 reduces to 1 over 4. So that's the way to think about it one way. I'm going to show you a different way. Hopefully this isn't going to make you crazy thinking about this. But if you don't want to think about it this way and you just want to straight up use this formula, I'm going to take a piece of paper and kind of add on to this. Here's another way to think about that. So if we know the probability of B given A is equal to the probability of A and B, which we know A and B is 1/7. And it's divided by the probability of A, which is 4/7. Let's see, right down here. So the probability of A given B is equal to the probability of A and B divided by the probability of A. So if you just want to just hardcore brute strength this, probability of A and B, you already know, it's a 7th. Right here. Probability of A, you already know, is 4/7. But then you got to know how to divide fractions. That's the trick. 1/7 divided by 4/7. You're not allowed to divide fractions, but you can keep, change. Okay. And then you could just cross out these 7s since they go into itself once. 1 times 1 is 1, 1 times 4 is 4, and you get 1/4, which is the same as what we got here. So that's a way to brute strength it if you want to, brute force it. So we know that the probability of B given A is 1/4. Okay, now they want us to take the probability of A and multiply it times the probability of B given A. Well, the probability of A is 4/7 times B given A is 1/4. And you can either go straight across and reduce, or you could just reduce early and get 1/7. Now, the last question is select the probability that is equal to probability of A and B. Well, the probability of A and B is 1/7, which is the same as the probability of A times the probability of B given A. So it's this guy right here. So the probability of A and B is A and B right here is 1/7. And the probability of A times the probability of B given A is also 1/7. So they are equal to each other. So this is equal to the probability of A and B. All right, so I'm gonna let you simmer on that. So you'd be very pleased to know we only have a couple problems left. So 2 more slides. The sales, so we're going to compute conditional probability using a two-way frequency table. And the reason it's called a two-way frequency table is because you can look horizontally and see that there were 29 people and 41 and 61 people in this no seminar row. Same for seminar 33 and 77. So you can look at it like horizontally. And then the other way is to look at it vertically. So you have 29 and 33 in no increasing, and 61 and 71 in increasing sales. So that's why they call it the two-way table. You can look at it a couple different ways. Okay, the sales for each of 200 salespeople were recorded 1 month. The sum of the salespeople took a sales training seminar and the rest did not. The next month's results are reported in the following two-way frequency table. Okay, so let's look at this. So we have 29 people that didn't go to the seminar and had no increase in sales. You have 61 people that didn't go to the seminar, but they did increase their sales. You have 33 people that went to the seminar but had no increase in their sales. You had 77 people that went to the seminar and had increased sales. A salesperson is chosen at random from this 200-person group. Complete the following, write your answers as decimals. Okay. Find the probability that a salesperson increased their sales. Okay. So we're looking at increased sales. We don't care about no increase. We don't even care if they have no seminar and a seminar. We just want to know what's the probability that they increase their sales? Well, we would need to add up 61 plus 77 to figure out what's that total here. So 61, 77 is 138. Okay. So the probability that salesperson increased sales would be this 138. They all increased their sales out of 200. So 138 out of 200. But they want this in a decimal form. Remember, it says write your answer as a decimal. So if you put that in your calculator, you're going to get 0.69. So it's a 69% chance that the salespeople increase their sales. So 138 out of 200 is almost 70%. So that's great. Find the probability that the salesperson increased sales given that she took the seminar. Okay, there's that given word. Remember, given changes that denominator. Okay, so the given that she took the seminar means that we need to be very careful of our denominator. Okay, they took the seminar, that's given. So the people that took the seminar was 33 plus 77. So we need a total here. So 33 plus 77 is 110. Okay, so that's going to be our denominator, given that they took the seminar is 110. Now we got to find the probability that the salesperson increased their sales. Okay, well, they increased their sales 77 out of the total 110 that took the seminar, increased their sales. So that's 77. So hopefully that makes sense. Is there evidence that oh, you know what I forgot to do? I forgot to put that into our calculator and give a decimal answer. So that is 0.70 once we put that in our calculator. Okay, so let's take a look. The probability that they randomly grab someone and the salesperson happened to increase their sales is 69%. The probability that they grabbed a salesperson, they've increased their sales, but they also took the seminar, that was the given, is 70%. So those are kind of close together. Is there evidence that a salesperson who takes the seminar is more likely to increase sales than a randomly chosen salesperson from the group? So we know that we have a 0.70 chance or 70% chance that the salesperson took the seminar and increased their sales against 69% that they just happened to increase their sales, but they didn't necessarily take the seminar. So if we look through these options, we're basically comparing 69 and 70. And they're asking us, do we think that taking the seminar helped lead to increased sales? And these are so close together that I'm looking at my no options. And I believe it's this one, no, because the probability found in part B is about the same as the probability is found in part A. So we're going to go with that one right there, but you need to read through those carefully. Okay, last problem. A survey showed that 23% of college students read internet news on a regular basis. Okay. And 83% of college students regularly watch the news on TV. Okay. And the survey also showed that 21% of college students both follow TV news regularly and read the internet news regularly. Okay, we got a couple questions to finish us off here. What is the probability that a randomly selected college student reads internet news regularly, given, whoop, there's that word, that he or she watches TV news regularly? Round your answers to the nearest hundredth. Okay, let's make a little key here. So the probability that they get their news from the internet is 23%. That's from the first line. The probability that they get their TV or their news from the TV is 83%. Okay. The probability that they get their news from both internet and TV they told us was what, 21%. Okay. And then they're asking us this question, the probability that a randomly selected college student reads internet news, so reads internet news, given, there's the pipe symbol, they watch TV for the news. Okay, so watching TV for their news is going to need to be our given. That needs to be our denominator. So watching TV for news is 0.83. All right, so that's going to go down here. And then the probability that they read or get their news from the internet is let's see here. Okay, the probability that they read the news from the internet, given that they watch TV news regularly, is going to look like this. So we know that because of the word given, we want to make sure that we have watch TV for news as our denominator, 0.83, and the top is going to be the probability that they are watching or catching their news through the internet and TV, which is 0.21. Now, if you divide 0.21 divided by 0.83, we're going to get approximately, I'm going to use the squiggles, 0.25. So there's a 25% chance that you randomly grab a college student and they read internet news regularly, given that they also watch TV news regularly. Oh, it's a crazy word this late. Okay, final question. What's the probability that a student watches TV news regularly, given that he or she regularly reads internet news? Round your answer to the nearest hundredth. Okay, the probability that they get the news, they watch it from the TV, given they read it, their news on the internet. All right, so given, we got to be really careful that the reading news on the internet has got to be our denominator, that's 0.23. And the probability that they are watching or getting their news from both would be 0.21. So this would be, if I can write this out here, which might make things a little easier, the probability that they watch TV and read their news from the internet divided by the probability that they read their news from the internet. Ugh. Okay, so 0.21 divided by 0.23 is approximately 0.91. I went ahead and just rounded to the nearest hundredth. Please check these calculations, make sure they look good to you. And thanks for sticking around for 4 different videos for week 4's Math 205 Survey of Mathematics from Wilmington University's homework problems. Take care.